See this question. In this question, there is a combination of lenses, convex lens, concave lens, convex lens, and you have to find the position of final image which is formed by this combination. Now see how to do these types of numericals. Now in these types of numericals, we will apply the lens formula, and for the lens formula, for this first lens, take this first lens, let this lens be L1. Now for L1, this is the object. The object distance will be 30. We will take minus 30. Focal length is given. Focal length is plus 10 centimeters. This is the focal length which is given. Now we will find the image distance, and for that we will use which formula? Lens formula. First lens L1. Now using lens formula which is 1 upon f is equals to 1 upon v minus 1 upon u. This is the lens formula. Now substitute the values. So if we substitute 1 upon f is plus 10, 1 upon v minus 1 upon minus 30. Now 1 upon 10 is equals to 1 upon v plus 1 upon 30. Take this term to the left hand side. So you will get 1 by 10 minus 1 by 30 equals to 1 by v. Now after taking LCM, you will get 3 minus 1, and this will give you 2 upon 30 is equals to 1 by v, and this v will be 2 upon 30 is 1 by 15, and take its reciprocal 15 centimeters. Now this is positive. You are getting positive. Positive indicates that the image is formed on the other side. Now we will indicate the position of the image. Now where the image is there? For this object, the image is at 15 centimeters from this lens. 15 centimeters means 5 plus 10 means here you will get the image. This is the image formed by the first lens. Why I am writing I1? I for image for the due to first lens. Now this image will behave as object for the second lens. Now we will use the same lens formula for the second lens. Now see the method for L2. Now this lens we are taking L2. Now for L2, what will be the object distance? Now since this image is behaving as object for second lens, so this will be the object distance. Means object distance is this one, which is 10. So u is equals to plus 10. So why we are taking positive? Because it is on the other side, on the right hand side. Now this you can find by this method also. See, this is total 15, 15 minus 5. 15 minus 5. You will get the same 10. Why? Because we have to find the distance of this image which is formed by the first lens, which will now act as object for the second lens. Now this will be the object distance, and this object distance is 10. You can find by this also 15 minus 5, which is 10. So this is u. Now what is its focal length? Focal length is given minus 10 centimeters. Focal length is given minus 10 centimeters. Now again apply the lens formula. 1 by f is equals to 1 by v minus 1 by u. Now substitute. So after substitution you will get minus 10 1 by v minus 1 by 10. Now you can see that these two will cancel. V is equals to 1 upon v is equals to 0. Means v is equals to infinity. Means now this second lens which is concave, this will form the image at infinity. Image is at infinity. Now after this again we will use the lens formula for the third lens. But listen, you can have the answer by trick. What is the trick? What is the concept? Concept is whenever the object, now since this image is now object for the third lens, means now the object is at infinity, means where the image will form at the focus of this mirror, of this concave lens. And what is the focus? Focus will be at 30 centimeters from this lens, means answer is 30 centimeters from this third convex lens. Now if you want to use the same lens formula, then you will get the same result. Now we are checking for that for L3. Now this is the third lens, which is L3. Now what is U? U is infinity. Why? Because this image which is formed by the concave lens, now it will behave as object for convex. Focal length is given plus 30. Now if you use the lens formula, then you will get 30 1 by V minus 1 by infinity. 1 upon infinity is 0. So you will get V is equals to 30. See, you are getting the answer same, right? So what is the position, the final position of the final image formed by this combination? This is the position, means the final image is formed at 30 centimeters from L3, third lens. You got the answer? So what is the concept here? This O is the object for the first lens. Find its image distance. Now the image formed by the first, which is here, this will behave as object for the second. Now using the lens formula, again find the image formed by the second lens. This is the image formed. Now this will behave as object for the third, and the image formed by the third will be the final image, and its position we have to find. So practice these types of questions. These types of questions are important as per board examinations, for the board examinations. Okay, thank you beta, thank you.